Okay, so this is the 2025 Higher Level Maths Leaving Cert paper 2, question 7a. Below is a scale diagram of a submarine. The body of the submarine is roughly in the shape of a cylinder with a cone at one end and a hemisphere at the other end as shown. Measure the lengths labelled R, D and H on the diagram above. Write the length of each correct to the nearest centimetre in the table below. So I've done that here. I've got 1, 10 and 3 centimetres. The actual total length of the submarine shown in the scale diagram above is 90 meters. So it's 90 meters from here to here. So we've got to use the measurements from part A1 to work out the actual lengths represented by R, D and H. Give each value in meters, correct to one decimal place. Okay, so the total length in centimeters is 14, 10 plus 3 plus 1. So in other words, 14 centimeters is equivalent to 90 meters. So that means 1 centimeter is just 90 over 14 meters. So that is 1 centimeter. That's our first one. So we can write that in anyway. When you do that to one decimal place, you'll get 6.4 meters. So all you got to do is just scale that up then to 10 centimeters. So we just got to take 90 over 14 and multiply it by 10. When you do that, you get 64.3 meters. That's for D. So for H, then we've got to take 90 over 14 and multiply it by 3. When you do that, you get 19.3 meters. Okay, next question then. The diagram below shows the body of a different submarine with a similar design. The dimensions of this submarine are all given in terms of x, where x is real. The hemisphere, cylinder and cone all have radius x. The submarine has volume 6,738 meters cubed, corrected nearest meter cubed. By solving the equation in x, find the total length of this submarine. Give your answer in meters, correct to one decimal place. Okay, so this is just one big volume kind of question. So let's write down what we're given. We are given that the volume of the submarine is 6,738 cubic meters. So first thing I'm going to do is find the volume of the hemisphere, or write down the formula for the volume of the hemisphere. So the volume of the sphere is 4 over 3 pi r cubed. So we have a hemisphere, we have half of that, so that's 2 over 3 pi r cubed. The next thing we've got to add is the volume of the cylinder in the middle. So that's just pi r squared h. And then we've got to add the volume of the cone at the end, which is 1/3 pi r squared h. So let's just stick in all our values. We got 6,738 is equal to 2/3 times pi times the radius in this case is x, so it's just x cubed. We've got to add pi r squared h, so pi times the radius, which is x, which we've got to square, and that's times the height. Now the height of our cylinder is this distance here, which is 7x. So that's just 7x there. And then we've got 1/3 times pi times r squared, which again is x squared, times h. The height of our cone here is 4x. We've got to multiply this by 4x. So this is the equation we've got to solve. It looks quite big, but it's not too bad really. So you've got, let's see, 6,738 is equal to. So first thing we've got here is the hemisphere. So we've got 2/3, we have pi, and we have x cubed. Here we've got 7x times x squared. So that's 7x cubed times pi. So it's 7 pi x cubed. And then out here we have a 4x times an x squared. So that's 4x cubed times pi, so it's 4 over 3. 4 times 1/3 is 4 over 3 times pi times x cubed. Okay, the next thing I'm going to do is just add up these things on the right hand side. So on the left hand side I've got 6,738. If you add up 2/3, 7 and 4/3, you will get 9. So it's just 9 pi x cubed. So finally then we have our x, well we'll do x cubed first. That's just 6,738 divided by 9 pi, and then the x is just the cubed root of that. So we've got 6738 over 9 pi. And we just got to cube root that. Okay, so that's our value for x. Now what we want, what we were actually asked for is find the total length of the submarine. So we have the x, we have a 7x and 4x. So that's 7, 8, 9, 10, 11. That's 12 of these x's. So what I've really got to do is just multiply this thing down here by 12. So 12x then is equal to 12 times the cube root of 6738 over 9 pi. Now when you do that, you get 74.397918. So we want this to one decimal place, so that's 74.4, and our units are in meters. Okay, next question then. A submarine is within route 58 kilometers of a point A and is within route 178 kilometers of a point B. The distance from A to B is 20 kilometers. So that's from here to here. And A and B and the submarine are all at the same depth. This is represented on the coordinate diagram below. The points 0, 0 and 20, 0 are shown. Part of the circles K and S are shown, where K has center 0, 0 and radius root 58, and S has center 20, 0 and radius 178, square root 178. The circle intersects at the point C and D, which are here. The submarine is in the shaded region, or the region that is inside both circles K and S. Write down the equation of the circle S. Okay, so that is reasonably straightforward. I think it's just going to be x minus h to be squared. So the center is 20, 0, so h will be just 20. So we got to square, and then it's plus y minus k. Well, that's just k is the y coordinate, which is 0, which we got to square, and then that's equal to r squared. Well, the radius of our circle is the square root of 178. So if you square that, you just get 178. So that's the equation of our circle S. Okay, the point C is 7, 3, and the point D is 7, minus 3. By using your answer to part A1, or otherwise verify that 7, 3 lies on the circle S. So all I got to do is put 7 in here and 3 in there and see, do we get 178? So it will be, let's see, 7 minus 20 to be squared plus y, which is 3, which we got to square. Is that equal to 178? It should be. Well, let's see, we've got 7 minus 20, which is minus 13. Square that. We've got 3 squared, which is 9. So we've got, let's see, 13 squared is 169 plus 9 is equal to 178. And that'll finally give us 9 9's 18. So that will give us 178 is equal to 178. That is it. Okay, so this is part 3. By using C7, 3 and D7 minus 3, find the area of the triangle DBC. So DBC is here, DBC. So you've got to find the area of this triangle here in square kilometers. So we know from what we're told that this here, D, is 7 minus 3. So this is 7 minus 3. And C is 7, 3. So the distance from D to C then is going to be 6 units. So that's 6 up along there. We know that we have on the x-axis out as far as here is 7. So it's 7 from here to here. And it's 20 out to here. So this distance out here must be 13. So if we take this, for example, as the base of our triangle, this distance down here is the base of our triangle. So that's half the base times the height. So that's going to be half of 6 times 13. So the area of our triangle, DBC is equal to half the base, which I'm saying is 6, times the height, which is 13. Half of 6 is 3, 3 13s, 39, and that is in kilometers squared. Okay, next question. Find the area of the acute angle CBD correct to the nearest degree. So we want CBD. So we want this angle here. Okay, so what I'm going to do is I'm just going to call this angle here alpha. I'm going to find this angle here and just double it. So what I'm going to do is I know that C is 7.3. So in other words, this distance here, this distance from here to here must be 3 units. So I'm going to use sine 3 over the square root of 178 is the sine of alpha. So in other words, the sine of alpha is 3 over the square root of 178. So if I get sine inverse 3 over the square root of 178, that'll give me alpha. So if I want the size of the angle CBD, I've just got to double that. So it's twice sine inverse 3 over the square root of 178. So my angle then is, when you do that, you'll get 25.9892 and so on. So that's going to be approximately equal to, this is our angle CBD. So that is approximately equal to 26 degrees. We need it to the nearest degree. Okay, next question then. The area of the sector ADC, so ADC, so this sector here, is 23.4837 square kilometers, correct to 4 decimal places. The area of the triangle ADC, so this triangle here, is 21 square kilometers. Using this, work out the area of the shaded region OR, so this shaded region here in the middle, that is inside both circles. Give your answer in kilometers squared, correct to 2 decimal places. Okay, so the way I'm going to do this is I'm going to work out the right-hand side, the area to the right-hand side of this dotted line, the shaded area to the right of the dotted line, by subtracting the area of the triangle from the area of the sector that we're given. So that'll give me the right-hand side of the dotted line. Then I'm going to do the same thing with this triangle and sector on the right-hand side. I'm going to take the area of this triangle and I'm going to subtract that from the area of the sector. That'll give me the shaded area to the left of the dotted line. I'm going to add those two areas. That'll give me the total area of the shaded region. So let's work through all of that. So the first thing I'm going to do is look at, that we'll say the right shaded region. So that's just 23.4837, and we've got to subtract 21. And when you do that, you get 2.4837, and that's square kilometers. So let's look at the left shaded region then. So the left shaded region is going to be the area of the sector on the right hand side. So that's the sector that's within the circle S. So the area of a sector, remember, is going to be pi r squared anyway. So it's going to be pi times the radius of the circle. The radius of the circle we're talking about is this length here. That makes up this circle S. So that's the square root of 178. If we square that, we get 178. So that's the area pi r squared. That would be the area of the entire circle if we were to go all the way around. We only want part of that circle, so we want a fraction of that circle. The fraction of that circle that we need is the angle here, which we've worked out previously as 26 degrees. So that's 26 degrees over the entire circle, which is 360 degrees. So that's the fraction of the circle we're talking about. That's the sector. Okay, so what we got to do next is subtract the area of this triangle here from C down to D over to B and back to C again. We've worked that out already as 39. So that is the area of the shaded region just to the left of the dotted line there. So if you do that, you get, let's see, you get 1.386918.891, and that's kilometers squared. So the total areas, in other words, the area of the shaded region is just going to be this number here and this number here added. So when you add those, you get 3.8706 and so on, and that's going to be we need this to 2 decimal places. So it is 3.87, and that's in kilometers squared. Okay, that's it for question 7.